Dear students, today we are going to perform a new practical. This practical is from group C and its practical number is 2. Now in this practical we have to find out a factorial of a particular number and we have to develop a assembly language program based on 8051 microcontroller to find out a particular factorial number. So let us begin with the practical. So what is a factorial of a particular number? So here is a formula to calculate a factorial. It says that n exclamation mark is equal to n multiplied by n minus 1 multiplied by n minus 2, and we have to reach till we get a number 1. Now this is a formula. Now let us take an example. Now in this example we are going to calculate a factorial of 4. So what we have to do is we have to multiply it by 4. This is n, and n minus 1 it has to be multiplied by 3, n minus 2 so it has to multiply it by 2, and at the last we have to multiply it by 1. So thus we get a 24 number. So factorial of 4 is nothing but a 24. Similarly, we have a second example in which we have a calculated factorial for 6. So we have to start with 6, that is n, then we have to multiply it by 5, then we have to multiply it by 4, then 3, then 2, and then 1. So here the hidden logic is we have to take the number from the user, slowly we have to decrement it by 1, and while decrementing it we have to multiply this number and we have to accumulate the addition. So that is the logic behind calculating a factorial of a number. Going to the practical, I will suggest that you should visit the site is called as mathisfun.com, and on this site even you can find out more information about the factorials and how to calculate that and how that is fun to being calculated. So here they have given how the factorial is being calculated. Even they have shown that there is a pyramid at the bottom. So here you can see that the factorial of 0 is 1 and the factorial of 5 is 120, and next to that if you put a number 6, its factorial is 720. As you know that our 8051 microcontroller is 8-bit microcontroller, and with the 8-bit microcontroller we can show the maximum number of 255. So we cannot calculate the factorial more than 5. Now, if you want to calculate, there could be some different method, but right now we are going to use a simplest method in which we are going to take a number which is less than 5 or equal to 5. In that case, we can see the factorial, and that is 120. So if you look at our manual, in the manual our aim is to write down an assembly language program to find out the factorial of a particular number, and then there are objectives like we have to develop an algorithm first to calculate the factorial, and then we will from the algorithm, from the flowchart, we will develop an assembly language program to calculate the factorial of a particular number, and then we have to verify the results. So these are our objectives. So once again the equipments will be your desktop computer and will require a kill IDE compiler for 8051. Now, if you look at the algorithm, here I have put down some things like user can feed his number from port number 1. So whatever the factorial that you want to calculate, that number has to be fed to the port number 1, and the result is shown on a port number 2. And the input that I am showing over here, this input number should be less than or equal to 5, because if you take a number 6, then the factorial will be 720 and it will be larger than 225, and your port will be unable to show the result, or it will show an incorrect result. So the algorithm to calculate the factorial is like this. So the number that user is going to feed, that we are going to grab that number from port number 1 and we are going to store that value within R1 register. After that we are going to set one of the register, that is R7 is equal to 1. Now in a multiplication we require two quantity. So one is within R7 and the second one is in R1. But in a case of multiplication, both quantities should be available within a accumulator and a register B. Then and then only multiplication can be performed. So the next step is to copy the value of R7 to the register A, and that is 1, and copy the value of R1 that is user defined to the B. After that we should multiply these two quantities. So it is 1 multiplied by the particular number, and it will be the same one, that is n. After that what we are going to do is we are going to decrement the value of register R1 by 1, and once again we are going to check whether R1 is less than or 0 or not, because we have to go on multiplying this step up to 1, not more than 1, not less than 1. So if it is not equal to 0 or equal to 1, rather say that, we have to go back to step number 5. So again we have to multiply it, we have to decrement it, and once again we have to multiply it. Now this loop will stop when r1 is equal to 0. That is means that we have already performed multiplication by 1, and in that case it will exit from this loop and it will send the particular value to the port number 2. So this is the algorithm for calculating a factorial of a particular number. Now let us look at the flow chart. So in the flow chart, we have a start, and after the start, we are going to read port 1. So from the port 1, we are going to get the user defined number, and we are going to store it in a register R1. After that, we are setting the next register, that is R7 is equal to 1. We are going to copy R7 to register A. We are going to copy R1 to register B, and that is a user defined number, and we are going to multiply A and B. So here we are performing multiplication, and after each multiplication we are decreasing the value of R1 by 1, and after that we are checking whether the R1 is equal to 0 or not. Now if it is not 0, we are going to repeat this step till R1 becomes 1. So it is multiplied by 1, and at the last step it will be, if it is equal to 0, then what we are doing, we are just sending a factorial number which is calculated to the port number 2 and a stop. So this is about the algorithm and the flow chart in this practical. So here is the program, as you can see that from the algorithm and the flowchart that we have developed. So first line is move R1 comma P. So P is our input. So from here the user can input his number. So here you can input your number, any number, which should be less than or equal to 5. So number should be less than or equal to 5. So that can be inputted. And after that we are setting up one more register, that is move R7 comma 1. So we have to start multiplication from 1, okay, and then we have to decrement it one by one. After that we are saying L call fact. So the fact is nothing but a subroutine which is calculating a factorial of a particular number. So it will go to the fact. Now here you can see that whatever within an R7, that is what it is 1, it is copied within an accumulator. After that we are checking whether R1 is 0 or not. If it is 0, we'll go, if it is not 0, then we'll go to the loop, and within the loop what we are doing is we are moving the second number, that is user defined number, we are transferring it to the register B. After that we are multiplying it. So within A we have 1, and within a B register we have a register B, so it is N. After that we are just checking, we are just decrementing a value of R1, which is a user defined number. Decrement jump if not 0. Then what we have to do, we have to loop it. So unless and until this R1 becomes 0, we have to loop it. So once it becomes a 0, this statement becomes a false, and once this statement becomes a false, it will return to the main program. In the main program it says that the calculated value, that is multiplied value, that is available within an accumulator, that will be transferred to the R7, and from R7 we are just transferring that value to the port number 2. So this is how we can calculate the factorial of a particular number. Now let us try and simulate this program in a kill compiler. So I have already set up this program in a kill compiler. So here you can see that the logic is very same. Now let us go to the debug mode and try to calculate the factorial of particular numbers. So as I told you that our one mistake is there. I think I have not assembled this program. So I'll go to start stop debug session. As I told you that whenever you load a program, you have to assemble that program. Okay, so once we have assembled this program, 0 errors and 0 warning, and the compiled this is compiled program. We'll go to start stop debug session. I should see only the factorial program. Okay, so before, as you can see, that we were seeing the two programs. One was for prime numbers and the second was for factorial, but the assembler can execute only one program, so that we have the error was because we have not compiled this program. Now we have compiled this program, so here is the main window. So as I told you, the user can input his number from port number 1 and it is going to be stored in a R1. So let us say that I want to calculate the factorial for 3. And from this, you can see that factorial for 3 is number 6. So when I run this program, at the last, I should get a 6 at port number 2. So here you can see that I am running in a continuous mode. So here you can see that a 6 is our output. Let us look at the other numbers, what happens with other numbers. Now I'll reset the CPU and let us input the number 4 and the P1, that is our user input, and let us run this program. So our output is an 18. So let us find out what should be our result. Our result should be 24 and we are getting an 18. Remember one thing, these are the hexadecimal number. So this 18 number is correct and the decimal number 24 and its equivalent hexadecimal number is 18. So this is how we can calculate the factorial of any number.